Picture this. You're a network planner at an airline, and you have a route on your desk that has failed every single feasibility study for the last decade. Call it Chicago to Manila, or Sao Paulo to Sydney, or Johannesburg to Los Angeles. On paper, the demand is there. Business travelers, cargo customers, a diaspora population that would fly it every single week. But every time your team runs the numbers, the airplane comes up short. Not by a lot. By a few hundred miles, by a couple of tons of payload, by just enough to make the difference between a route that prints money and a route that bleeds it. For 15 years, that gap has quietly killed hundreds of potential routes across the industry. And then, in March of 2026, without unveiling a new airplane, without a single new engine, without a splashy press conference with a ribbon and a model plane on a table, Boeing closed part of that gap. They did it with a certificate, a piece of paper from the FAA that changed one number. And that one number is about to reshuffle the long-haul math for airlines all over the world and hand Boeing a weapon in its oldest and most bitter rivalry, the one against the Airbus A350. Let's get into what actually happened, why it's a genuinely big deal, and why you should still be a little skeptical of Boeing right now, even as you're impressed by the engineering. To understand this story, you have to understand one number that almost nobody outside the airline business thinks about: maximum takeoff weight, or MTOW. Think of it like the towing capacity on the sticker inside your truck's door. Your truck might be physically capable of hauling more, the frame and the axles might be able to take it, but the manufacturer has certified it to a specific number, and that number is the legal, insurable, safe limit. Push past it, and you're not just breaking a rule, you're operating outside the entire safety envelope that regulators tested and approved. Airplanes work exactly the same way. Every commercial jet has a maximum weight at which it is permitted to leave the ground, fully loaded with fuel, passengers, cargo, and crew. That ceiling determines almost everything an airline can do with the aircraft: how far it can fly, how much it can carry, which routes are even mathematically possible. And for two versions of the Boeing 787, the 787-9 and the 787-10, that ceiling just moved upward for the first time in years. Before we get to the new number, rewind to 2011, because the 787 story doesn't start with this upgrade. It starts with a genuine gamble Boeing took almost 20 years ago. When the 787 Dreamliner entered commercial service with all Nippon Airways, it wasn't just another new jet. It was the first wide-body airliner in history built primarily from carbon fiber composite rather than aluminum. Roughly half the aircraft's structural weight is composite material, woven from carbon fiber strands thinner than a human hair, into a fabric that's stronger than aluminum and dramatically lighter. Composite doesn't corrode the way metal does. It can be molded into continuous curved shapes instead of riveted sheet by sheet. And Boeing built the fuselage in one-piece barrel sections, rather than the traditional patchwork of aluminum panels. The payoff was enormous. The 787 burns around a quarter less fuel than the wide-body jets it replaced. That single efficiency gain is the reason airlines have opened more than 530 brand-new nonstop routes since the aircraft entered service, routes that simply didn't pencil out economically with older aircraft. By May of 2026, Boeing had logged over 2,400 orders and more than 1,270 deliveries of the Dreamliner, making it by a wide margin the best-selling wide-body aircraft ever built. But the 787 launch wasn't smooth, and it's worth remembering that before we get to the upgrade, because it actually explains why this conservative certification happened in the first place. The Dreamliner program was famously delayed. Originally slated to enter service in 2008, it didn't actually fly its first commercial passenger until late 2011, 3 years behind schedule, after a string of issues ranging from bolt shortages to software integration problems to, most seriously, a battery fire investigation in 2013 that grounded the entire global 787 fleet for over 3 months, while regulators and Boeing engineers worked out a fix involving a redesigned battery containment system. Those early years were rocky enough that skeptics openly questioned whether the composite airframe gamble had been worth the trouble at all. But the airplane that emerged from that turbulent start turned out to be exactly what airlines needed, and the fuel savings alone were large enough to justify the growing pains in hindsight. Here's the thing about the 787 that airlines have grumbled about quietly since day one, though. Boeing certified the airframe conservatively. Engineers built in structural margin, extra strength beyond what the certified weight limit actually used, partly because that's standard practice for a brand new composite design where regulators want a wide safety cushion until real-world service data accumulates, and partly because nobody at Boeing wanted to be the airline discovering an unknown failure mode in a carbon fiber airliner the hard way, 30,000 feet over an ocean. So for over a decade, that margin just sat there, unused, baked into the airframe, but locked out by the certification paperwork. Airlines knew it was there in some form. Pilots and engineers who worked closely with the type would occasionally reference it in industry forums. the sense that the 787 was quietly undercertified, relative to what the metal could actually handle. But knowing a margin exists and being legally permitted to use it are two completely different things in aviation, and for 15 years, nobody could touch it. That changed this year. In March 2026, the FAA approved a higher maximum takeoff weight for the 787-9, adding approximately 10,000 pounds, about 4,540 kilograms, to bring the new certified limit to 557,000 pounds. On the larger 787-10, the increase is even bigger, roughly 14,000 pounds or about 6,350 kilograms. Now, weight increases alone don't mean much to a general audience, so let's translate that into what airlines actually care about. Airlines can spend that extra allowance in one of two ways. They can convert it into range. The 787-9 gains more than 300 additional nautical miles, and the 787-10 gains somewhere between 400 and 460 nautical miles. Or they can convert it into payload, extra cargo or extra passengers, with the 787-9 picking up around 3 metric tons of additional capacity, and the 787-10 picking up around 5 metric tons. To put 400 nautical miles in perspective, that's roughly the distance between London and Paris, tacked onto the tail end of a transoceanic flight for free, without burning any additional fuel beyond what the aircraft was already certified to carry. Now here's the detail that should genuinely surprise you, and it's the part Boeing's own engineers keep hammering home in briefings. They didn't touch the fuel tanks, they didn't touch the engines, they didn't launch a new variant with a new designation and a new marketing name and a new type certificate. Every 787-9 and 787-10 that has rolled off the production line since December 2025 was already physically, structurally capable of flying at this higher weight right off the factory floor. What changed was the piece of paper, the certified operating limit, and that piece of paper only exists because Boeing spent years running one of the most extensive structural fatigue programs ever conducted on a commercial airliner. Here's roughly how that process works, because it's more interesting than it sounds. Engineers take a complete airframe, not a flying one, a dedicated ground test article built specifically to be destroyed in slow motion, and mount it in a massive test rig full of hydraulic actuators. Those actuators repeatedly flex, twist, pressurize, and load the structure to simulate the stress of an actual flight. Takeoff, climb, cruise, descent, landing, cabin pressurization and depressurization, turbulence loads, the works. Then they do it again. And again, thousands of times around the clock, compressing years or even decades of real-world wear into a controlled lab environment where sensors are watching every millimeter of the structure for the first sign of a crack, a delamination, or any kind of fatigue. For this particular certification, Boeing put the test airframe through 165,000 simulated flight cycles, a number engineered to represent multiple lifetimes of airline service, far beyond what any single aircraft would realistically accumulate before retirement. At the end of that punishing test program, the composite structure showed zero fatigue, not reduced fatigue, not fatigue within acceptable limits. Zero. That result is what ultimately gave the FAA the confidence to sign off on unlocking capacity that had been engineered into the airframe from the very beginning, but never certified for actual use. And it's also a quiet vindication of the original conservative design philosophy. Boeing built in more strength than it needed, and 15 years later, that decision turned into a free upgrade. If the kind of story you like is the engineering behind a business decision, not just here's a new plane, but here's why an existing plane suddenly got more valuable, that's exactly the kind of analysis this channel is built around. So if you haven't already, this is a good moment to hit subscribe, because we're closing in on a milestone and every subscriber genuinely helps keep this channel independent. So why does any of this matter to an airline's bottom line? Because airlines run a constant optimization problem. How do you extract the maximum possible revenue out of every kilogram of capacity on every route, at every price point, every single day? And airlines don't all want the same thing out of this upgrade. Some carriers are range constrained. They have a route sitting in a spreadsheet somewhere that has always been just barely out of reach. A non-stop from a mid-sized Asian hub to South America, or a direct connection from an Indian metro straight to a North American gateway that currently requires a stop. For those airlines, an extra 400 nautical miles isn't a nice to have. It's the difference between we can't fly that route and we can fly that route and make money on it. Other carriers aren't chasing extreme range at all. They're flying shorter or medium long-haul routes where the real constraint isn't distance, it's weight. Full passenger loads plus full baggage plus belly cargo pushing right up against the old MTOW limit, forcing the airline to offload freight or leave seats empty just to stay under the ceiling. For those carriers, 5 extra metric tons of payload capacity on the 787-10 means either more revenue-generating cargo or the ability to sell every seat without last-minute weight juggling. Boeing's chief project engineer for this program, John Murphy, has described the intent behind the upgrade in pretty blunt terms. Some operators wanted the 787-10 to reach longer routes. Others wanted the 787-9 to haul more payload, even at the cost of some range. And the new certified weight limit was engineered specifically to let each airline choose which of those two problems it wants to solve using the same base airframe. That's the elegant part of this. It's not a one-size-fits-all upgrade. It's a menu, and every airline picks the version of more that actually solves their specific route math. It's worth pausing on just how unusual that flexibility actually is in aviation. Normally, if an airline wants more range, the answer involves buying a different variant entirely, or accepting a payload penalty by blocking off seats or limiting cargo to keep the aircraft under its old weight limit. A common workaround airlines have used for years on borderline routes, essentially flying a full-size airplane half empty just to make the distance. That workaround is expensive in a way that doesn't show up on a balance sheet as cleanly as a fuel costs do. It shows up as lost revenue, seats that could have been sold, cargo that could have been carried, sitting empty because the old weight math didn't leave room for them. The MTOW increase attacks that problem directly, because it doesn't force an airline to choose between range and payload before the airplane is even built. A carrier can adjust how it uses the extra allowance route by route, season by season, even flight by flight, depending on winds, weather, and how full the cabin happens to be that day. That kind of operational flexibility is difficult to put a precise dollar figure on, but for network planners, it's often more valuable than the raw range or payload number by itself because it removes constraints from the planning process rather than just shifting them around. Now, here's a question worth sitting with for a second before we move on. Given everything you've just heard, which of the two variants do you think airlines will lean toward ordering more of once this upgrade becomes standard, the range-focused 7879 or the payload-focused 78710? Drop your answer in the comments because the order books over the next couple of years are going to answer that question for real. Of course, none of this is happening in a vacuum, and this is where the rivalry comes in. The Boeing 787 has, since its launch, competed directly against the Airbus A350 family, specifically the A350-900 and the larger A350-1000. And for years, the A350 has genuinely had the upper hand on the most extreme ultra-long-haul missions. Airbus built the A350 with a bigger wing, more internal fuel capacity, and a higher certified maximum takeoff weight than the original 787, and that gave it a real edge on the routes, sitting right at the outer limit of what any wide-body can do. The A350-900ULR, the ultra-long-range variant, is the aircraft that made Singapore Airlines famous for flying the longest scheduled nonstop route in the world, connecting Singapore directly to New York, a flight that pushes past 18 hours in the air. That's the kind of mission where the A350 has simply had no direct 787 answer. Until now, sort of. The new MTOW certification doesn't erase that Airbus advantage, and it's important to be honest about that. The A350-1000 in particular still outranges and outlifts the 787 on the most extreme sectors on the planet, and Airbus isn't standing still either. The A350 program has its own incremental upgrades in the pipeline, and Airbus has made no secret of wanting to defend its ultra-long-haul crown. But what this Boeing upgrade does is narrow the gap on the much larger number of routes, where the 787 and the A350 are competing head-to-head in the mid to long-haul market. The Dubai to London kind of mission, the Doha to Chicago kind of mission, the everyday long-haul flying, that actually makes up the bulk of both aircraft families' order books, rather than the handful of headline-grabbing ultra-long-haul routes that get all the attention on aviation media. And that distinction matters more than it might sound like at first. Ultra-long-haul routes like Singapore to New York are genuinely rare in the global route network, spectacular, headline-friendly, but a tiny fraction of total wide-body flying worldwide. The real battleground between the 787 and the A350 is the much larger universe of 8 to 14-hour missions, European hubs to the Gulf, North American gateways to East Asia, African capitals to Europe. That's where airlines buy in bulk, where fleet orders run into the dozens or hundreds of aircraft, and where a few hundred extra nautical miles or a couple of extra tons of payload can tip a fleet planning decision from order the A350 to order the 787, or vice versa. Every additional mile Boeing squeezes out of the 787 without changing the airplane itself is, in a very direct sense, a mile taken off the table for Airbus to compete on. And the commercial numbers suggest the 787 was already winning this fight even before the upgrade. As of mid-2026, the 787 program sits at more than 2,400 total orders, compared to roughly 1,595 for the entire A350 family. In 2025, Boeing outsold Airbus company-wide for the first time since 2018, a genuinely significant shift after years of Airbus dominance in total deliveries. The 787 remains, by a comfortable margin, the most popular wide-body aircraft currently in production anywhere in the world. The timing of all this order activity is not a coincidence either. In 2025, Qatar Airways placed an order for 130 Boeing 787s, one of the largest Dreamliner commitments in the program's history. Delta Airlines, a carrier that had, somewhat famously within the industry, never operated a single Dreamliner in its entire fleet, placed its first ever 787 order in early 2026, ending one of the more notable holdouts in the wide-body market. And Emirates, one of the largest long-haul carriers on the planet, and long associated almost exclusively with the Airbus A380 and the A350, is preparing to become a Dreamliner operator for the first time in its history. Boeing, by most accounts, is now taking in 787 orders faster than its production lines can actually turn them into delivered aircraft. For every airline currently sitting on a Dreamliner order waiting for delivery, this MTOW upgrade is effectively a bonus. Extra range or extra payload capability arriving on an airplane they'd already committed to buying, at no additional cost. So, genuine engineering win, real commercial momentum, order book advantage over Airbus, it would be easy to end the story right there on a triumphant note. But that would be irresponsible, because capability and credibility are not the same thing. And Boeing has spent the last 5 years very publicly losing the second one. Here's the reality check. Over the past 5 years, Boeing has been managing the fallout from serious manufacturing quality problems that grounded or delayed production on more than 120 787 aircraft. The most infamous of these was the so-called shimming issue, microscopic gaps at the joints between fuselage sections caused by imprecise assembly work, tiny enough to sound trivial and serious enough to require extensive rework before those aircraft could be safely delivered. Fixing that backlog took years, and Boeing didn't finally clear it until February of 2025. In 2024, a Boeing engineer and whistleblower, Sam Salahpour, went public with allegations about improper fuselage assembly practices affecting both the 787 and the 777 programs, claims serious enough that the FAA opened a formal investigation. Boeing has denied the substance of those allegations, but denial doesn't undo the reputational damage, and that FAA investigation is still ongoing. Then, in early 2025, Italian authorities uncovered a fraud scheme at a supplier called MPS, which had been falsifying quality certifications on more than 4,800 components that ended up in Dreamliner production. The supplier no longer exists as a company, but the episode raised uncomfortable, still unanswered questions about exactly how much oversight Boeing actually had over its own supply chain. Questions that a weight certification upgrade, however impressive, does absolutely nothing to answer. It's also worth pointing out how these two storylines, the MTOW win and the quality control mess, collided in time almost exactly. The same production system that finally cleared its shimming rework backlog in February 2025 is the one now shipping airframes certified for this new higher weight starting in December of that same year. Which means every one of these upgraded aircraft rolling off the line today is coming out of a factory system that only recently proved it could hit a basic quality bar consistently after years of very public struggle to do so. That's not a reason to dismiss the MTOW achievement. The engineering behind it is real, independently verified by an outside regulator, and not something Boeing could simply talk its way into. But it is a reason to hold two thoughts at once. The airplane itself is more capable than it used to be, and the company building it is still, by its own admission, through years of corrective action plans filed with the FAA, in the middle of proving it can build airplanes to a consistent standard, delivery after delivery, without the kind of shortcuts that caused the shimming problem in the first place. There's a broader pattern here too, if you zoom out far enough. Composite manufacturing at this scale was genuinely new territory when the 787 program launched back in the 2000s. Aluminum airplanes have 100 years of accumulated manufacturing knowledge behind them. Generations of engineers who know exactly how metal behaves, exactly where it tends to fail, exactly how to inspect it cheaply and reliably. Composite fuselage sections were, and in some ways still are, a newer discipline, with newer inspection techniques, newer non-destructive testing methods, and a supply chain that had to be built up almost from scratch to support the sheer scale of production Boeing wanted for the 787. Some of the quality problems that have plagued the program, including the shimming issue, trace back to exactly that kind of growing pain. A manufacturing process, still maturing under the pressure of a production rate that kept climbing, with suppliers spread across multiple countries all needing to hit tolerances measured in fractions of a millimeter. None of that excuses the failures, but it does help explain why a program that has produced genuinely groundbreaking engineering, like this MTOW increase, can exist right alongside a program that has also produced genuinely serious manufacturing lapses. It's the same underlying tension between innovation and industrial discipline that has followed composite aviation manufacturing from the very beginning. So where does this leave the two companies heading into the rest of the decade? Boeing has, at least for now, restored some of its commercial momentum. The order numbers from 2025 and early 2026 make that clear, with Qatar's mega order, Delta finally entering the Dreamliner fold, and Emirates preparing to fly its first 787s after decades of loyalty to other aircraft families. The MTOW upgrade adds a genuine performance argument on top of that momentum, one that costs airlines nothing extra and requires no new pilot training, no new spare parts inventory, and no operational changes, beyond updated performance charts in the flight manual. That's about as close to a free lunch as aviation engineering ever gets. Airbus, for its part, isn't sitting idle. The A350 still wins on the most extreme long-range missions, and Airbus has every incentive to keep pushing its own incremental improvements to defend that territory, because losing the mid-long-haul battle to a resurgent 787 would be a real strategic problem for the A350 program's future order book. Expect this rivalry to keep playing out not in dramatic all-new airplane launches, which take a decade and tens of billions of dollars to develop, but in exactly this kind of incremental certification-driven skirmish. A few hundred more miles here, a few more tons of payload there, each one small on its own, each one meaningful to the airline crunching the numbers on a specific route. So here's the honest way to think about this MTOW upgrade. It is a genuine, well-earned engineering achievement. 15 years of unused structural margin, unlocked through one of the most rigorous fatigue testing programs the industry has ever run, translated directly into extra range or extra payload for every airline flying the 787-9 and 787-10. It gives Boeing real ammunition in its ongoing fight against the Airbus A350, and it's arriving at exactly the moment when major carriers like Qatar, Delta, and Emirates are placing record Dreamliner orders. But it's one good chapter inside a much longer, messier book about a company that is still working to rebuild trust with regulators, suppliers, and airline customers after several genuinely damaging years. Airlines placing 787 orders today are making a bet that Boeing's production discipline has actually improved for good, not just temporarily. This upgrade gives them a very real reason to feel confident about the aircraft itself. The manufacturing history gives them an equally real reason to stay cautious about whether their delivery date actually holds. That tension, real engineering progress, sitting right next to real institutional risk, is basically the entire Boeing story right now, and this MTOW certification is just the latest chapter in it. Thanks for watching all the way through. If you want more breakdowns like this one, the kind that go past the press release and into the actual engineering and business decisions behind it, stick around because there's a lot more of this rivalry still to play out.